Okay, so this is lab 6 for the natural language processing with Orange book. And this is the second of two videos on sentiment analysis. The first sentiment analysis video, lab 5, talked about rule-based sentiment analysis, which is a slightly easier procedure because with rule-based sentiment analysis, you're taking your verbal textual data, a consumer review or something like that, you tokenize it, um, pre-process it, remove the stop words, make it all lowercase. Then you just take the process tokens, which are sort of like your keywords, and they get mapped to a sentiment lexicon. We demonstrated the Vader and the LH method in the lab 5. Machine learning based is the second method, but machine learning based sort of requires a little bit of a knowledge of machine learning. And if you take or look at my data mining course, you sort of need to understand some basics of data mining in order to understand machine learning, including how to classify things, classification methods, and what labeled data means. Labeled data in a nutshell means that for sentiment analysis, it means that you have your review and then you actually already have a tagged sentiment. And you need to have this already in order to do machine learning based or create it with like cluster analysis. All of those techniques are taught in data mining. So this lab sort of does have you can still sort of understand this lab without data mining, but to fully appreciate what the machine learning basis is, um, you want to know a little something about labeled data. Um, the rule-based method doesn't require any knowledge of that, but this method does. So machine learning models learn from labeled examples instead of fixed rules. So again, you have to have in your data the labels there. Or as I teach when I teach cluster analysis, you can actually cluster data and then create labels. But generally speaking, the machine learning techniques are always based on labeled data. And that's what supervised learning is all about. Supervised learning means that you're working with labels and you're not working with unlabeled data and starting from scratch or mapping to a lexicon. Okay. So this is the book that these labs follow. It is available on my website, which again is right here. And these are the different topics, but the AI stuff is all here. The data is a free download. I'm going to use some of this data today. So if you want the data to follow along, it is here. You just click on it and download it. And then this is also the book. Now, this is the main textbook, meaning that these labs are just labs. They're the hands-on stuff. So the main textbook maps to both the Orange labs and it also maps to the R labs. The R labs are slightly more advanced level. The Orange labs are more like lower level, non-data science, computer science major type people, more introductory. Pretty much anybody should be able to follow these labs. The R labs are coding based and use R programming, so they're a little bit more challenging, a little bit more advanced. But all of the materials are here in the natural language processing section. This is all the NLP stuff. There are so the slides here as well, not just for this lab, but for the whole book. Okay, so that's that. Okay. So what we're going to do with this is, first of all, we're going to go in Orange and load a data set. It's a labeled data set that has reviews, and then it has a sentiment that's already mapped. Now, why are we doing sentiment analysis when you already have sentiment? This is essentially our training data. Again, this is the machine learning basis. So you have to actually create, when you do something that's machine learning based, you have to actually create your model using something that has those labels in it. And then you can take new things that are not labeled with the model that you've created and use it to use the created model to classify new stuff. But you have to, when you initially create a classification model, you have to have labels in order to do that. Okay. So we're going to load the data set just using the file widget. And then we're going to create a corpus, because remember, whenever we do NLP stuff, we want to be working with a data object called a corpus, which effectively is your like text holding data object that you use for NLP. And you can do that simply by adding a corpus widget. And then we're going to pre-process. This is the lab 2 stuff. So if you have not watched these labs in series, lab 2 is this one right here. And it teaches a lot about pre-processing. So that's what we're going to do like quickly. But if you want to know more about pre-processing, which is a hugely important step in natural language processing, this is the business of taking the like English written text, stripping out the stop words, lowercasing stuff, and tokenizing it. So it's huge. And we're going to use the pre-process widget and just do all the steps at once. Okay. And then we are also going to encode the text, which means we're going to turn it into a numeric format. This was not necessary in the rule-based. It's necessary, though, in the machine-based, because the machine-based, we're doing underlying mathematics and modeling with it, and we can't do that unless it's encoded. So this is lab 4. If you wanted to go back and learn more about encoding, we are going to use the TF-IDF method, which is explained in lab 4. This is also, again, like these are just the labs. If you want to learn about like all the details of the context of this, it's in the book. And so to encode text, we're going to use a bag of words and we're going to set it to IDF, which is the TF-IDF method. Okay. And so let's go and do this first in orange. So let's load the data, make a corpus, pre-process it, and encode it. Okay, so I am in orange. And I'm going to start with a new workflow. I'm going to add a file widget. I am going to upload my data, which is called generic reviews. And it's just a CSV file. Again, this is in that data set available at dataanalyticscurriculum.com for a free download. So this is the data. I'm going to hit reload. I just always hit reload. And then I'm going to make a corpus out of the data with the corpus widget from text mining that, again, if you don't have this installed, you have to install it from options, which is in the other videos. So I'm going to load a corpus, load it into a corpus. Good. Then I am going to actually look at it because we haven't looked at it. Corpus viewer just looks at data. It doesn't actually do any processing. It's just a viewer. And so that's the link I clicked on. So this is what it looks like. Okay. So it's mostly a text file of just generic reviews. Literally, it's just a really simple made up file of reviews. And then the sentiment labels are actually in here. You can't see them through this. Oh, no, you can. Okay. So the sentiment would be positive with this one, we're supposed to be negative. So this is all set. That's what our data looks like. The idea is just that's just the row number. We don't need that. Okay. Good. Yeah, we're good. Okay. So next we want to pre-process this, and in the text mining menu, there's a pre-process text. This is lab 2 to refer back to. Because if I tried to re-explain everything in every video, they'd be like 3 hours long. So I'm flowing my data in, making a corpus out of it, because I have to make a corpus in order to use these text mining widgets, because they're based on a corpus data object. And so pre-process, double click on this. I'm going to tokenize, which means I'm going to split my words into individual, like split my sentences into individual words. I'm going to make everything lowercase, and I'm going to remove my stop words with my stop word dictionary. Okay, good. To look at it after pre-processing, because I just always like to make sure that it looks right. First of all, don't stick stupid widgets on there like accidentally. I do that a lot. Like I accidentally put these little squigglies in there. And I sort of choke my work. Okay, we don't want that. There we go. There, careful. Okay. So what this looks like after pre-processing, at first you're like, it didn't do anything. Always make sure the little show tokens is clicked. So we've stripped out the stop words like I and this, and we've lowercase everything, and then the tokens are what we're operating on. And then we're going to encode the tokens with a bag of words widget, which we're going to use not the bag of words method, but the TF-IDF method. So we're going to flow it through here, and we are going to click on this. and it's set to IDF. I don't know exactly what the default is, but it's set to what we want, which is this is going to be the TF-IDF method. If you want to double check, because like me, I'm a little neurotic and I want to make sure it looks right, look at it in a data table and you will see the encoded values, which you have to scroll over. So you see that associated with the different words like love is 3.5 and so forth. So you actually now have encoded numbers associated with the words, which is what you want. Okay. So we're all kind of set up now to actually do our sentiment analysis. We've uploaded our data, we made a corpus object, we pre-processed it, and we encoded it. So we are ready to go in terms of like actually running the sentiment analysis. So let's talk more about what that is actually going to do. Okay. So up to here, we are done in orange. And then in order to do the machine learning, and again, this is kind of the data mining background. When you do data mining and make models, you take the model, you take the data that you have, and you split it into a training and a testing. So I'm going to do a 70%, 30% split. Usually I do an 80-20, but I'm going to do a 70-30 because this is a fairly small data set. And you want to make sure that you have like a reasonable amount of data to test. So the training data is what the model is going to be built on. Okay. But we want to validate its accuracy before we start using it on novel data. So the testing data is to evaluate it. And this is something that a lot of time is spent on data mining, like in my data mining course, and a lot of the videos for that course are on here, although I'm going to redo that one too to go with the new books. But this process of model building and splitting models and making sure that you have, this is the sampling and splitting. This should of course be random. You don't want to do this on sorted data. So that is something that you make your models based on the majority of the split. You make your models based on, typically this is 80-20, but I do use 70-30 when I'm doing small data sets. And then you evaluate the model. Okay. And in orange, there's a data sampler widget that you just apply to the data and set the percentage and it does it for you. Okay. So your data gets split into testing and training subsets. Okay. Which are mutually exclusive. You're either in the testing set or the training set. Like you don't want to use the same data in both sets. So this is what the data sampler looks like. And you set it. Now the data sampler is not, this is not specific to text mining. This is used in all kinds of models. Machine learning is not unique to text analytics. Machine learning is used for just regular numeric stuff too. So you need to set this, what proportion of data. When it says this proportion, this is the training data. Okay. And that's basically it. Okay. And then we're going to actually use for our classification method, because now what we want to be able to do is we're going to build a model based on the training data. So the training data is going to build a model, and the target variable is going to be whether it's positive or negative sentiment. And so we're going to build a model that takes in the text and then builds this. So it is actually a logistic regression model, because this is just going to be positive or negative stuff. So we're going to use logistic regression, which again, in the data mining courses is explained. It's generally taught in sort of more advanced statistics courses too. But logistic regression is basically just your regression kind of stuff where you have an input variable. This is your equation of a line, except that your output is a binary outcome of plus or minus, and it's a probabilistic model. So we're going to use linear logistic regression rather. There are other methods that you could use for this, like LDA and Bayes and other things. But what we're going to do is we're going to take the training data and we're going to build a mathematical model that, based on a text, which is now encoded. So this is numerical input. So this is effectively your text input. And then you're going to build a model that predicts whether it's positive or negative sentiment. That's kind of the simplistic way to put it without getting into all the logistic regression details. Again, this is all like in the book as well. It's in the NLP sort of textbook. It's also something commonly studied in more advanced statistics and the data mining course. I would say my data mining course is an excellent background for a lot of the other AI stuff. Very popular course, fills almost every semester. Yeah. So, anyways, um, that's effectively what we're going to do. We're going to run this model and we're going to create this. Then we have a model. Okay. When we have a model, we're going to evaluate it using the training data. So we split our data into the training and the testing. Okay. This we're going to make the model with, and then this we're going to evaluate with. So essentially, we have a model that predicts whether or not we have positive or negative sentiment based on the text. Okay. And then we're going to the reason we can evaluate with the test data is the test data is labeled too. So we're going to basically determine like how correct on the testing 30% of the data, applying it to the model, how correct is the model in terms of like predicting positive or negative. If it works fairly well, then we can go and use this model on novel data and we're kind of set there. If it doesn't work and it's really just kind of no good, you want to come up with a different model or method. Okay. So the way we're going to do this in Orange is a little quirky, and I have to actually show you in order for you to understand this. Orange is using like these sort of widgets for doing Python programming. So sometimes it looks a little sort of like bizarre, not super intuitive, like how to set it up. And this is one case where to me it looks a little bit weird. Okay. So let's go into Orange and set this up. Also very important is to make sure the connectors. Now these are the things between widgets, and you can click on them and make sure that like what you're sending is what you should be sending. So I'll show you that. And so this is, for example, looking at from the data sampler to the logistic. This says data sample underneath it. And so you click on this. This is what this is, and you want to make sure that it's sending the sample data, which is the training data and not the remaining data through the model to make the model. I'll show you this. Okay. So it should ultimately look like this, and this is a like zoom in of what we're going to set up. So the data comes in here. We do our 70-30 split. The 70% goes to the logistic regression. This makes the model. Okay. This is the 30% remaining data. Now, what's going to happen is we're going to evaluate the model with this. So this part does not get through the logistic regression because it's not like part of what's making the model. The training data makes the model gets sent to test and score, but the testing data also gets sent to test and score. So this model here is going to test this data, and then we get our evaluation results from that. Okay. So let's go in Orange and do this. Okay, so I'm back in Orange. I have my encoded data. And I'm going to take my encoded data and I'm going to send it to the data sampler. Now, the data sampler, these techniques are not specific to text mining. These are like generic data mining techniques that you use in any data mining, regardless of your data type. So, and we are at this point, because our data is encoded, we're actually using numeric data anyways, because that's why we encoded our data. So at this point, we're sort of like not necessarily in NLP world anymore, we're in data mining world. So the data sampler is under, I kind of forgot. It's under transform actually, which is kind of strange. So I'm going to send my data to the data sampler as a corpus object still. Here's where I do my proportion of data, which I'm going to set to 70%. Okay. And go ahead, you need to hit the sample data button down here. I don't think it runs correctly. Okay, so this actually down here, there's 30 rows of data and it's 22.8. And that actually, you can see the details on this. So does that make sense? Oh, I said it accidentally at 71. That's why. That's why. I moved it. There we go. Let's try this again. There. yes, 70% of the data would be 21 and 30% is 9. So it's very subtly down here. You can barely see it. So the sample data is, that's the training data. And then the remaining data is the testing data. Orange is not English speaking, so the way it describes things is slightly different than the way that I would. Okay. Then the logistic regression widget is under model. Okay. So we're going to put this here. We're going to flow the training data here. So, but when we do that, we have to be careful with what's on the connector. So what's on the connector, which is this thing right here, we want to make sure that this says data sample and not remaining data. This is going to flow the training data to the model to make the model. I don't know why this is like unhappy. By the way, select method range. I don't know if it really super matters, but I usually use range. Okay, so that's that chain. Then we're going to add a test and score widget. That's what's going to do our like model evaluation. And we're going to add that. That one is under the evaluate menu. And so we're going to add that at the end here. So we're going to feed the model to this, but we also need to account for the testing data, the other 30% of the data that's not going through the model. So the other 30% of the data is going to go straight from the data sampler to test and score. And again, click on, see, this is where you have to be careful. Click on this. We don't want the sample going there. We only want the remaining data. Okay. So we don't want that. We want this. Then hit go. Now it should, and it says training. Oh, okay. I forgot to do something which is actually good that I'm going to leave this in here. I need to have a target variable. In other words, I haven't specified my target variable. So I want to do that. And I'm going to do that by adding a data table, joining, no, sorry, not a data table, but a select columns. I'm going to do that before I go in here. So I'm going to change this a little bit. I'm going to add this select columns that I stole from the transform menu. And I'm going to stick this in here. I'm going to stick this in here. There we go. So I'm actually pathing my data now into this. Why am I doing this? Watch. Because I want to actually have a target variable. This is actually very important. I don't know what all that is. Hang on. Double check this. It's the right data. Hit reload. Select columns. Oh, this is all the tokens. That's why. Okay, cool. And then data sampler. Now it should be happy. So what I did is I had to actually set, and you have to actually have this target value, which is, this is the sentiment label in the data. I forgot about this step. So without that in there, the model's not going to run because it doesn't know what the the outcome variable is. Okay. So now everything should be fine. I should be able to click on here and get results, and I do. So now I get these results. Okay. Which don't look super good, but don't look horrible either. Remember, this is just a little toy data set. So, and this, by the way, like this would be negative and this would be positive. This isn't displaying like correctly. See, it's a small data. What it's complaining about is it's a small data set. So try actually going down here. Let's do cross-validation. Now, cross-validation essentially means it's going to repeat. So let's do some repeat sampling. Number of folds exceeds the data set. Okay, we can't do that. Let's do 5. These are the results. They don't look super great, but it's not a super great setup. So the overall model average, now I don't know why this is like, usually it displays nicer than this. Okay. So the overall average is basically classification average, that's CA, 44%, which isn't great. So basically this is not a terrific model, which is kind of interesting. But that's not really the point. The point is to demonstrate how to actually make the model. Okay, so I could actually resample just to see what happens. Now, every time you sample and hit sample data, it's going to resample, so you're going to get a slightly different result. See, although actually I get the same result, which is kind of interesting. So, and this is set right, so we should be okay. I'm not quite sure why it's so miserably unhappy, but it is. It is running and it is fine running, but it's not super happy about. It's just not a super good model because our accuracy is pretty low. Another way to look at this, and probably a more important way, is to look at it through a confusion matrix. So you're going to get the confusion matrix also under evaluate, and you go on here, and you go here. Okay, and click on this. Now, what the heck is this? This is actually a matrix of these numbers are various metrics of accuracy. They don't look fantastic. I mean, they're not, you know, it's a small data set. The classification doesn't look great, but so the confusion matrix is actually easier to interpret. So what this is there's 30 text values in here. Okay. When we sample and run this data sampler, 21 of them are going to go to build the model, and the remaining 9 are going to go into this evaluation and the confusion matrix. So what we see here is the remaining 9, and it's essentially saying the predicted are the labels that we would expect. These come from the data. So, and then this is the, oh no, sorry, the predicted are the ones that the model is, the actual ones come from the data. So the actual ones are coming from here, these sentiment things. These are the actual ones that came from the labeled data. Then the predicted ones are coming from the model. So we know from this that the model is actually running just fine. There's nothing mathematically wrong with it. It's actually pretty good in that sense. So you like select the correct, select the misclassified. So we have 4 misclassifications. Oh no, those are not misclassifications, positive and positive. These are the misclassifications. These 2 are the correct ones. That doesn't seem right. Positive predicted is positive 4. Okay, so that's the 4 out of 9. That would give us the 44%. 5 of them are actually misclassified. So 2 actual positive ones are predicted to be negative, and 3 actual negative ones are predicted to be positive. But that's just one sample. So we can go back and sample again and kind of like maybe hope for the best. So sample again, we should get different numbers here. And we don't, which is interesting. Hang on. So let's do stratify. Oh, I don't want to do replicable sampling because that will give me the same sample each time. Yeah, so stratify. Now we should get totally different numbers, and we do. So this one though is still equally bad. We still get exactly the same thing. 4 correct. Let's see if we can do a little bit better. Yeah, so this one looks a little bit better. So this sample, I only get 2 misclassifications out of 9. So my numbers, my overall classification accuracy is going to be 78%. Generally, like this is a really small data set, so we're making really small, a small misclassification can have a bad looking rate. So what we've done is we've created a model where we inputted text data. We made a corpus out of it. We pre-processed it. We encoded it to be numeric. We set our target as the sentiment. We sampled the data so as to split it into training and test. The training data makes the model. The testing data flows through test and score, and we look at how accurate the 9 tests, which is 30% of the data. Based on this run, it was pretty good. We got 7 correct out of 9. And so what this now would have, what does this have to do with sentiment analysis to begin with? Now, if this model is as good as making 7 out of 9 correct, we can take completely unlabeled new data and classify it using this. That's to tie everything together and finally finish what this is all about. So we make a sentiment analysis classification model from the data. This is very different from making it from, taking your word tokens and mapping to a sentiment lexicon where it just says, the word happy maps to positive sentiment. This is taking labeled data that is our labeled data using the labels in our labeled data and making a model to predict sentiment that we can now use to put new stuff in. It's just like basic linear regression when you can put new values into a regression model for the future and predict the future. So this creates what's called a machine learning sentiment analysis model, which of course, if you're using something novel and proprietary and you want to make your own model like this would work great. I mean, the rule-based ones are sort of more simplistic. This is something that is a little bit more advanced and requires a little bit of like data mining, machine learning knowledge. Okay. So to wrap this up, oops. Okay. We looked at the metrics and performance. Um, and we ran it a couple times. We got one that was pretty good. The others were not so good. So each time you sample by randomness, you're going to get slightly different results. Okay. This is one that I ran statically. It has 70% accuracy rate. That's not too bad. 6 out of 9 correct. Generally, obviously, you want this to be greater than 50%. If it's greater than 50%, you're doing better than random chance. 7 out of 9 is actually pretty good. You're hardly ever going to get a perfect classification. You have to have really, really good data to get that. Anyways, and the confusion matrix to look at the results. This is your data values, and then this is your predicted values. These are the ones that are like correct, accurate. So this one was the 6 out of 9. And this is the 66% accuracy. 7 out of 9 would be even better. So yeah. So that's what we did. We built a machine learning sentiment model by loading and processing data, encoding the text using a training logistic regression model. There are other methods other than logistic regression that behave fairly similarly, but there's different subtleties for the different kinds of models. That again is something I cover in data mining with different types of classifiers. Evaluate using accuracy. Again, this is covered in data mining, the area under a curve method. The confusion matrix, I think, is generally the simplest method to look at the results, these guys. Machine learning methods, the good thing about these, unlike the fixed rule-based methods, the rule-based methods, there has to be some dictionary and some pre-existing definitions of the words of whether they're positive or negative. And they're not sort of flexible and adaptable, and that's why it's called machine learning. So you can use it with novel stuff, and the computer itself and AI based stuff is learning on new data and novel data to be able to discover new patterns and adapt. And you can do that with this method. So that is a really kind of cool way of sentiment analysis. And yeah, so this is lab 6. Again, all of the resources and materials are available on my dataanalyticscurriculum.com website. The data itself is completely free. The books are sort of relatively inexpensive. And it's good material for courses and stuff. Okay, so that was lab 6. Thank you for watching.